This is a short lesson on the continuation of identities in advanced functions here. Just, lesson 6.4 at the end, example 3, we just need to finish C and D. So remember, when you're looking at an identity, the idea is to make the two sides at some point along the process be the same. And there's a couple of things that you need to do when you're thinking about an identity. Of course, like, one thing is that what is on one side, for instance in this question, what is on one side is going to be a single term, whereas on the other side we have two terms, right? So we know that, like, sooner or later something's going to have to cancel, something's going to have to maybe use a common denominator like we did in a previous question, or we're going to have to expand maybe these formulas and try to get them to look more similar. Now, as I was saying, last time, the best thing to do here is sort of, look at which side you feel that you can get started on and work on it until you kind of exhaust the options, and then you switch to the other side. So, the final thing about this one here we're looking at is that if you look at the arguments, remember the arguments are the things being subbed into the function. And here the argument is x, and here the argument is y, and here the argument is a sum and a subtraction. We know those arguments sooner or later are going to have to be made the same. Now, since I don't really have a sine x cos y identity, I don't really recognize that, I don't think there's much I can do with what appears here on the left. I do at least have an idea for something to do on the right, which would be, I could look at using my sum of angles formula to expand this, right? That I know that sine x plus y, according to my formula, is when you're working with sine, you keep the operation the same, but you mix the functions. So, for example, this first one would be sine x cos y, okay, plus cos x sine y. Okay, so that's the first part of this thing expanded. And then if I go to look at the second one, okay, so then what I'm supposed to do is add, and I'm going to stick this whole thing in brackets because just to make sure I follow the signs, right? I mean, it's adding, so I guess it doesn't really matter, but let's do it anyway, just to be in the habit. Now, when you subtract with sine, again, you mix the functions together, so sine x cos y, and you keep the operation the same, cos x sine y. Okay, now when you look closer at this, you will see that sine x cos y is repeated twice, right? So we can add them together, 2 sine x cos y. Meanwhile, cos x sine y, this is a positive and this is a negative, and so they cancel. And so what we're left with is actually the other side, right? And the left side is equal to the right side, and that is all that it takes for something like that. So in my opinion, this is a rather easy one. This would be like a 2-mark question on the test, where it really only takes one move or a couple of moves to solve, right? Not really like the one we were working on last time, where maybe we had a couple of false starts, or maybe we tried things that didn't go anywhere, or whatever. And as usual, if you do try something that doesn't go anywhere, keep it, right? Like, submit it as part of your process. Now, of course, if you end up solving it, you can erase the part that didn't work. But if you don't end up solving it, then showing me that you tried a few different alternatives, may make the difference between, 1 mark and another. So this one, quickly, again, I see that there's a multiplication, there's different arguments here, there's a bunch of sums. I mean, I think a good thing to look at would be to attack these arguments here, and just let's use the cos formulas to change them. So the cosine rule, when you're adding angles together, is the same function, cos x cos y, but the opposite operation, minus sine x sine y. Okay, so that would be how you would split up this first one, and then you're multiplying it by cos x cos y plus sine x sine y, And so that is how we expand here the left side. So once again, remember, we're just going to keep this separated when we're doing a proof. Okay, so now here, when I'm looking at this, what I have to do is FOIL it, right? Because again, if you look on this term, you know, everything's expanded, whereas this one is you know, factored, right, or multiplied. So I'm gonna want to FOIL. So let's FOIL. So again, first times first, right, would be this times this. So you get cos x times cos x, which is cos squared x. Then you get cos y times cos y, which is cos squared y. Then you go to the outside. So the outside would be this one and this one. And you get cos x, cos y, sine x, sine y. So you just get them all mashed together. The inside term is actually the same thing as what we just said, but negative. So it's negative sine x, sine y, cos x, cos y, which those two things are going to cancel. Okay, and that leaves us with finally we have the last, which would be this one and this one, and there you're going to get sine squared x and then sine squared y. So when you expand this, okay, so we foiled it, right? Now we're going to collect the like terms and we'll write down what we've got. And by the way, I should add, this would also be negative, right? Because the negative sign here is going to mix together. So what we're left with here when we do this, okay, we have cos squared x, cos squared y, take away sine squared x, sine squared y. Now, you know, this looks a little bit closer to what the other one looks like, but you can see there's still going to be some sort of problem here, right, where like something has to happen with the signs, and something has to you know, give here in terms of something else I could do. So one of the things you can do here when you get to this stage, you know, maybe not sure what the next move is, you know, you can always use the graph to check and make sure that your steps so far worked. So for example, like if I do cos, I'm not actually sure. Actually, you know, I should say this one may not. This one may not work because it's using double variables, right? It may struggle with this because it's a multi-variable, but let's see, it might work. Well, I don't think that really helps us. It doesn't seem able to draw. Oh, you know what, actually? Probably because it's probably drawing something in 3D. Yeah, okay, so hold on. So let's go back. So okay, so it's drawing us this like wavy surface, right? And are they the same? So that's the original surface, and then this is the new surface, and they do look the same to me, right? They do appear to be perfectly identical. I don't see anything that makes them different. Okay, so anyway, so they are identities. So let's go and make sure that the step that we just did is actually right. Okay, so I'm going to type out our step. So cos squared x, cos squared y, minus sine squared x, sine squared y. So sometimes when you're going through the process with this, you know, you can like type in the step that you got to and make sure that you haven't made a mistake, right? So like I can see that the thing I've created is the same as the two other ones. So I know what I've done so far is okay. Again, it may not be right, it may not be helpful, but at least it's okay. Now I'm thinking here a couple of things we could try. One of the things we could try is we could notice that this is a difference of squares, right? That this is something squared, take away something squared, right? Not sure if that's actually going to help us get to where we want to go at the end of the day, though. Another thing we could think about, we could divide We could try to factor out something. We could also replace sine squared with cos squared, right? Remember, we also have that option. Maybe that's actually the best way to proceed, because one of the things I can see about the other side is that all the sine squareds are gone, right? So maybe, right, maybe it's a good idea to, for example, say that sine squared x is equal to 1 minus cos squared x. And then we could say the same thing with sine squared y is 1 minus cos squared y. I mean, maybe this will help. I mean, it's hard to tell with this, right? You just kind of got to go with what you think makes sense. So let's see. If I replace that, I get 1 minus cos squared x and 1 minus cos squared y. And then I think if I go ahead and FOIL this second thing, I think it will look a lot more like what the other side looks like. So let's see what it looks like if we FOIL this. 1 times 1 is 1, and of course let's just make sure we stick this in a bracket. Okay, so again, I'm going to put all this in a bracket. So 1 times 1, then I get 1 times negative cos y, cos squared y. Then I get negative cos squared x times 1, cos squared x. And then I get positive cos squared x, cos squared y. Right? And that's because, when you finish foiling here, you do the last times the last. Now, because this is a negative, right, if we distribute that negative to the rest of it, if we distribute that negative to the rest of it, just give me one moment. Then we just got to follow it through. So okay, so we have a negative 1. So we have negative 1. Then we have cos squared x, cos squared y, subtract cos squared x, cos squared y. So that's going to disappear completely, okay? And then we have negative, right? This is not an equal, it's a negative. We have subtract negative cos squared y is going to be plus cos squared y, and then subtract negative cos squared x is plus cos squared x. And I believe at this point we do actually have what the other side shows, right? Which is a cos squared x, which is positive, a cos squared y, which is positive, and then a negative 1. So that is everything about the identities. Okay, you can go through those two. Again, there are a bunch more in the book that are good. If you would like to raise one as a question, you can raise one in the discussion forum, would be good, or bring it to class next time. Tomorrow is also fine. Okay, so that's it. That's going to be good for lesson 6.4 about identities. As a sort of final thing, let's just go back to the idea of what are some of the things that are sometimes helpful if you get stuck, right? If you get stuck, right, usually working with the more complicated side is a good idea. Sometimes you can replace tan, cotan, secant, cosecant using all sine and cosine. I'm going to add one more thing here about, a common denominator is sometimes a really good strategy, right? That especially if you need to change addition into multiplication the way we did in the really hard question. So if you need to change two terms that are being added into two terms that are multiplying, a common denominator can often be a way to accomplish that. And finally, let's make sure we mention you have to have the same argument, right? So, and remember, the argument is whatever's inside the equation. So like if one side of your equation has a tan 2x and the other side of your equation has blank 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 tan x, for example, you know at some stage of this process you're going to have to address that these arguments are different. Okay, so everything with identities is up here. Like this chart is a nice summary of all of them. And when you're stuck, try something else. Try not to erase your work, but rather just start in a new area, so that you can show the various things that you've tried, because they count.